Man, the GLM team is just on an absolute roll. It feels like just yesterday they released a new vision model, and boom, now they've open sourced this incredibly powerful text-to-speech model. It's got the brain of a large language model, the precision of flow matching, and the emotional smarts of reinforcement learning. The promise? Studio quality, emotionally rich, and instantly clonable speech. So today, we're going to put it through its paces. We're going to install it locally and take it for a real test drive to see if the reality actually lives up to the hype. All right, so here's the game plan. First, we'll talk about what makes this new AI voice so special. Then, we'll pop the hood and see how it works. After that, we'll get into the secret emotional sauce. This is the really cool part. And of course, we're going to put it to the test before giving you the final verdict, the hits and the misses. Okay, so first things first, let's unpack what GLM TTS is actually promising here. I mean, the claims are pretty ambitious for a brand new open source model. Right off the bat, they're not messing around. They're calling it magically natural. So we're not just talking about another small step forward. The goal here is speech that's genuinely expressive and human-sounding, not just another robot reading a script. That's a really high bar they've set for themselves. And just look at this feature list. It's a powerhouse. We're talking zero-shot voice cloning, meaning you can clone any voice with just a tiny 3 to 10-second audio clip. That's wild. Then you've got a motion control that's boosted by reinforcement learning, really high-quality output in both Chinese and English, and it can even stream in real time. It's the whole package. So the big question is, how does it pull this off? How do you get from plain old text-to-speech that's complex and full of emotion? Well, it's not actually magic. It's a really clever two-step process. Okay, think of it like this. In step 1, you have a big, large language model that acts like a scriptwriter. It reads the text and decides exactly how it should sound. You know, the rhythm, the pauses, the feeling. It turns that whole plan into a sequence of speech tokens, which are kind of like musical notes for a voice. Then, in step 2, a second model, the artist, takes over. It looks at those rough notes and turns them into a perfect, high-quality audio painting that you can actually hear. But what really makes this thing special, what could make it a true game changer, is its secret emotional sauce. And the key ingredient here is something called reinforcement learning. This is how the voice really comes alive. So what is reinforcement learning? Well, the simplest way to think about it is like training a puppy. When the AI generates speech that sounds good, maybe more natural, or with the right emotion, it gets a reward, like a little digital treat. So instead of just being trained on right and wrong answers, it's actively experimenting and learning to chase those rewards to get better and better. And these are the smart judges that hand out the rewards. The AI gets scored on a whole bunch of things. Does it sound like the voice it's trying to clone? Is it pronouncing all the words correctly? Does the emotion sound real and not fake? They even have a judge for how believable its laughter is. So the model isn't just learning to read, it's literally learning how to perform by trying to get a high score from all these judges at once. All right, enough theory. That all sounds amazing on paper, but we wanted to see how it actually holds up in the real world. So we decided to get our hands dirty, install it on a local machine, and run some tests of our own. So the first step is pretty straightforward for anyone who's played with these models before. We just clone the entire project right from their GitHub page. And next up, we run a quick command to install all the different Python libraries and dependencies that the model needs to run. Again, pretty standard stuff. But it was during this installation that we realized something important. This model is very new. We're talking bleeding edge. We ran into a whole bunch of warnings and little errors along the way, which tells you the code is still being actively worked on and refined. It's definitely hot off the presses. So after we got through the setup, it was the moment of truth. We fired it up and started with the basics, just standard text-to-speech in both Chinese and English. And you know what? The results were really impressive. The quality was super high and crystal clear. I will say the English could sound a little flat or monotonous sometimes, but overall a very strong start. All right, so after running all our tests, how does it all stack up? Let's break down the official data and compare it to what we actually found in our hands-on test drive. Now, if we look at their official numbers, things look really good. Check out that CER column. That stands for character error rate. You want that number to be as low as possible, because it's basically a measure of pronunciation mistakes. And their RL version has the lowest score. It's the most accurate. At the same time, it scores really high on speaker similarity, which means it's great at copying the voice it's given. So on paper, it's a real contender. And our own test drive pretty much confirmed this. The hits are undeniable. The standard text-to-speech quality is fantastic, and that whole idea of using reinforcement learning for emotion is just brilliant. But there were some pretty big misses. The main voice cloning feature has a major problem right now, and the whole project just feels a little unfinished. And this was the showstopper. 2 seconds. That was the biggest miss of all. When we tried the zero-shot voice cloning, it didn't matter how long our text prompt was. It only ever produced a 2-second audio clip. We tried over and over with different inputs, different voices, and the result was always the same. This points to a pretty significant bug or a major limitation in the version that's out right now. So look, GLM TTS isn't perfect today, but the core ideas here are incredibly powerful. The progress in the space is moving so fast, you can easily imagine them fixing these bugs in a week. The potential for this tech is massive, everything from new accessibility tools to completely changing how we create movies and games. But it also gets us thinking about a future where this stuff is flawless, which leaves us with a really important question to consider. What does it mean for all of us when our own ears can no longer tell the difference between what's real and what's AI?